actually they're seals for hydraulic cylinders. They're not ones for rotating shafts, the ones I found anyway. So there you go. Right then, so what we've got to do is add on some bosses for these bearings. So what I shall do, and this will act as a reminder for all those people that have barely started their output case. So right. So we'll open this up, and we use the same procedure for putting in bosses as we did on the other case. So, extruded boss, and we do from the front plane. We're going to offset from the sketch. So the sketch has the diameter of the bearings on it. So for this one, we shall offset by 8mm. This is the input shaft. And this all has to be a guess at the moment. We're going to do offset and, I don't know, 30mm say. So that means that's where the boss is going to start, and then we'll do a length for the boss, and we'll just guess at the moment 50mm. There you go. Yeah. Right, I've obviously done too much. The 30mm was too much because I can't actually see it inside the case, so I need to drop that back a bit. So that's all right, we can edit that. Let's make it 20mm then. There you go, see it now. And we'll have a second boss here, so extrude. Front face. Quite a lot of you who handed in your models, you have managed to integrate the master sketch into one feature, and very often it was the very last feature. So what I suggest you do is you just delete the last feature, and that will get you your sketch back. Okay, so this time for the mid shaft I'm having a 10mm wall, and we'll do an offset of 20 again, I think. I know I can't do 30, so 20. Still, I think. Okay. And then I'll do a cutout for my bearings. So there's an extruded cut, and again front face, front plane, and this time we'll do convert entities. That's the trick, so that you don't absorb your sketch. So convert entities, select that, that's got that converted, got that, and I don't know, we'll go in the other direction, and 50, that'll do for the moment. Okay, so one more. This one is a slightly bigger bearing, so I'll maybe make it 60 instead of 55 perhaps. Change the direction. Okay, so that's where we are at the moment. Close that, save that. Yep. Okay, so I've got some bosses for those now. Now then, what I should do is adjust those bosses so that they fit the bearings perfectly. At the moment, these two bearings aren't quite level with each other. Now I could adjust it so they are, or I could just leave them where they are. I sort of was almost obliged to make them level here because these bosses were going to blend together, so it was much easier if I could just machine them together. but I don't think these bosses will blend together because these two bearings are smaller, well this bearing is smaller, so I don't think they are going to blend together, so therefore I don't have to have them level, okay? But you can make them level if you want, the same as you did on the other one, and you do that by just adjusting that, what we call the left gap on the input shaft or the left gap on the mid shaft, or both if you like, to arrange for the outer raceways to be level. However, I won't do that. So what I need to do is measure how much I need to change all these things. So we'll zoom in here, like so. And for the input shaft, and I'm going to write these down because it will be quicker if I do that. So evaluate, measure. If I take from this corner to here, that's 7.5. So I need to make it plus 7.5. With a selection, then the recess I need to make minus 11. Clear that. Clear that again. 5.75. Awkward size, but never mind. And 12.25. Okay, so let's go into the gearbox and have a look at that. So, if we start off with this one, we've got to make it 7.5 deeper. Okay. And the next one, we have to make that 5.75 deeper. Then we've got these recesses, so this one I have to take away 11, so that's going to become 39. And on this one, we have to take away 12.25, so 2.5 from 5 is 2.75, so 42.75. Okay. And I suppose we will go out and just check to see if that's correct. There you go, that's all lined up there perfectly. My case there, I don't really have enough room to get in a fillet, so I need to make the case slightly deeper, only a couple of millimetres I think. And what I'll do is I'll put on the draft on there as well, and the fillets at the same time, so right then, so we'll select that, make it a couple of millimetres deeper, should be enough. Then we need to do this draft on here, so draft, you have to do these one at a time unfortunately. just section this for a moment so I can look on the split line and make sure that the draft has gone in correctly. There was one or two people had in draft back to front, which makes it impossible to cast. And you can see there that that's tapering in the right direction, so you'll be able to pull your die out or your mould. Okay, so it's got that. Turn the section off, and we'll put on our fillets around here. So we'll put on 5 fillet, constant radius. So 1 there, 1 there. Now, strictly speaking, those are just overlapping. But actually, if you try and put in between a face fillet to blend between the two bosses, you end up having to put in some great big monster of a thing for it to work. So I'm happy enough with that, those just touching. Okay? Right then. So where are we? Right, next thing then. We need to put in a recess for the back of the bearing. If I pull this up, if you have a taper roller bearing like this, you'll see that to avoid the rollers actually catching the gear case, you have to put in a recess. You can see here, and there's a depth of CA and a diameter of DA. Okay? So, that's what we need to do. So, for my particular bearing, let's have a look. My particular bearing is 32005X, and all I need to do is find the right table. This is the table out of your notes here. 32005X, and I need to find the diameter DA. So it's roughly in line with the word P of paragraph there, so we'll just scroll up. Sorry, it's sideways. So here's DA min and DA max. So it's going to be 40 to 42. Okay, so I'm just going to lock that in the mind for a moment, and it would have a depth of 3. Okay? So, the next thing I need to determine is what type of seal I'm going to put on there. Now, my shaft diameter is 25 millimeters. So I need to pick a seal from the tables that will fit in there. And in your book of notes, so on page 610, it gives the basic sizes for the seals. It gives very little information. It just gives the internal diameter, the outside diameter, and the length of the thing. So that's on page 610. And you will see that there's, sorry, 810, not 610. You will see that for a 25 diameter, there's actually 3 sizes. There's 25 by 40, there's 25 by 47, and at the top there is 25 by 52, and all of those are 7 thick. I think I'm going to use the one in the middle. That's usually the one I would go for. So that has an internal diameter of 25, an outside diameter of 47. Now the reason I'm doing this at this point is because I've just worked out the size of that hole that's got to go through to allow clearance for the bearing, and I said it was 40. Well, 40 is clearly less than 47, and if I just put the hole going through rather than just doing it to a depth, it would actually leave a 3.5 millimetre step going around the circumference for the oil seal to press up against. So that's actually nearly perfect. Now, sometimes it doesn't work out, and what you have to do, sometimes your seal will be a smaller diameter, and it's just because of the size of the bearing, is you have to put in a recess to that depth of 3 millimetres in my case, and then move a bit further out again for a reduced diameter down to allow something for the seal to butt up against. If any of you find it doesn't work out, I'll sketch it out for you by hand. But anyway, for me it does work out. So I can put in a hole of 40, so that's what I'm going to do on my model. Okay, so all I'm going to do is extruded cut, select that face there, I'm going to draw a circle, find the middle of the shaft, so there it is there, draw a circle like so, put on a dimension like so, and that's going to be 40. And we'll basically do through all. Okay, so that's fine. Now then, what do we want to do next? We know we've got to have at least 3 millimetres before the seal, and the seal was 7 millimetres thick, so that makes 10. But actually, if you look in your notes, sorry, wrong table. If you look in the notes for a seal, the recess for a seal has to actually be deeper than the seal itself. This is to allow room for the lead on and still give some support. So for a 7 millimetre thick seal, you need a recess of 7.3. I'll call that 7.5, I think. So it'd actually be 7.5 plus the 3 for the clearance for the bearing. So that's 10.5. So if we go to the model, and what I'm going to do is measure the distance from the end of here to the end of here. Help if I selected the tool, wouldn't it? Here onto here, and that's 38.5, and I don't need 38.5, I need 10.5. So basically I've got to reduce the length of that boss by 28 millimetres. Okay, so that's what we'll do. So select that boss. And currently it's 50, so we're reducing it by 28, it's going to be 22. And if you get it wrong, you'll soon see, so it's not a problem. Okay, and now I'm going to put in a recess on this side to accommodate the seal, and that's going to be the outside diameter of the seal, which was 47. By the length of the recess, which it said 7.3, but I'm going to make 7.5. So we'll do another extruded cut. Extruded cut. And we'll select this face here. We'll do a circle concentric with this one. So that's 47. Okay, and we'll go in 7.5. Put in 7.3 if you wish. Okay, so that's got the recess for the seal. And if my calculations are correct, the length of that little cylinder there between the seal and the bearing should be 3 millimetres. So we'll just double check that, evaluate. I'll just select that. And no, I should have done it the other way. Just measure from here onto here. And that's 3 millimetres. Okay, let next thing I've got to do is add on a chamfer in there so that the seal can be assembled. So if we look at this little diagram again, it says a 5 to 10 degree angle, and it actually gives it the length that's not chamfered, which is an interesting way of doing it. Well, that's close to 6, it's 5.95, so I'll call it 6 because I've rounded the other number. So 6 from 7.5 is 1.5, so I need a 1.5 by 10 chamfer. Okay, so select this, feature, chamfer, and we put in here our 1.5, 1.5, put in here our 10, and then we select, well, it already thinks it's selected the corner, we'll delete those. So it's this corner here we want. And for some reason it always does it in the wrong direction, it's doing it sort of sideways, but there's flip direction, and that makes it then go down into the bore. So you see you've got a nice shallow chamfer on there now for assembling your seal. Okay, I suppose while we're here, what we'll do is we should also put on a recess at the bottom of that bearing bore as well, so that that bearing doesn't rub. So for me, my bearing was a 32206, so we're looking at the tables here. And it's just next to that 8, so my DA value needs to be between 52 and 56. I tend to go for the smaller size, the 52, and again 3 deep. Screw bit cut. Okay, so that's got that done. I suppose we might as well finish off that boss actually. If I measure the length of the boss as it stands, evaluate, so measure from here onto here, and that distance is 30, and